Hey, this video is going to define what an acid and a base is. So let me go ahead and pull this up so we can go over this. Okay, this is going to be using notes page 7 in your packet. So when you did the intro to acids and bases on pages 3 and 4, it kind of already introduced the ions that are present in acids and bases. And you can see with when you put acid into water and it dissociates into its ions, acids always give us H+ ions. And bases, when they get added to water and dissociate into its ions, they're going to give us the OH negative ions. So because bases give us the hydroxide ions, the negative ion, there's always going to be some kind of positive metal ion attached to that hydroxide. So when you dissociate it into water, you usually end up with the metal cation and the hydroxide anion. Now, because the acids are going to dissociate to produce the hydrogen ion, which is a positive ion, that acid is going to be attached to some kind of negative anion as its other ion. Okay. All right, so one thing that we want to kind of go over before we go into these definitions of acids and bases is the dissociation of water. So we saw on page 3 that water is a neutral substance. It's not an acid or a base because it actually can self-dissociate, self-ionize, and produce a hydrogen ion and a hydroxide ion. Now this picture doesn't necessarily show a hydrogen ion. It shows an H3O+ ion. That H3O+ ion is called a hydronium ion, but it's used interchangeably with a hydrogen ion. So I wouldn't be too concerned about it. H3O+ is equivalent to H+, all right? Because of the way that because of the water is bonded to itself, and because it's a polar molecule, it has this really high electronegativity difference between the hydrogen and the oxygen. When the waters get close enough to each other, when they hit just right, one water molecule can take a hydrogen atom off of another water molecule, ending up with this hydronium ion and the hydroxide ion, okay? Now, because of the dissociation of that, the acid, when it dissociates, is always going to increase that amount of hydrogen ions in it, and the way that the base dissociates is always going to increase the hydroxide. So our first definition is the Arrhenius definition. So this basically goes with what those images were showing at the beginning. Acids have hydrogens in the formula. Acids are going to dissociate and give us hydrogen ions. Okay. Bases, they're going to have an OH in the formula, and they're going to produce hydroxide ions when it dissociates in water. That's the first basic traditional definition of acids and bases. Acids have hydrogen, bases have hydroxide. The problem, though, is that it was discovered that not all bases actually had hydroxide ions in the formula, like ammonia. Ammonia is NH3. It's a base, but it doesn't have OH in the formula. It's a base because it's still going to take and produce, it's going to take a hydrogen, but it's going to produce hydroxide ions in the water. Okay, that's why it's considered a base. So we had to fix this definition. So they came up with a second definition, a better definition for acids and bases. It's the Bronsted-Lowry definitions. The definition for acids hasn't really changed. Acids still give away a hydrogen ion. So you can see in this image here that you have this molecule here. It's giving a hydrogen ion over here. So on this side, now this thing has 3 hydrogen ions, and this thing has no hydrogen on it, okay? So when you look at the actual formula written in symbols, you have HCl. Well, this H has now gone over to the water, so that's why you're making H3O+, hydronium, which is basically the same thing as a hydrogen ion, like I said, and a chloride ion over here, okay? So that definition hasn't really changed. The base definition has changed a little bit more, though. Now we are thinking not in terms of an OH ion in the formula, but that it accepts a hydrogen ion. So acids donate the hydrogen ion, bases accept the hydrogen ion. And when they accept it, that's how they end up producing the hydroxide ion in solution. So here you've got, now let me erase my drawings first. Here you've got NH3, all right? That's gonna be a base. It's gonna accept a hydrogen, all right? So it's gonna accept a hydrogen from the water. When it does, you can see that it ends up having 4 hydrogens over on this side. And because it took a hydrogen from the water, you end up with that OH hydroxide ion being produced in the solution. So, acids are proton donors. We say proton because H plus, the positive sign means it lost an electron. So essentially a hydrogen that has lost an electron is just a hydrogen positive proton because it just has 1 proton left. So acids are proton donors. They give away a hydrogen. Bases are proton acceptors because they're going to accept the hydrogen. Acids and bases are going to be on the reactant side of the reaction, okay? So when we have to identify acids and bases, we're looking on the reactant side for the acid and base. Now there's such thing as acid-base conjugate pairs, okay? So the conjugates are gonna be on the product side. The acid and base are on the reactant side, the conjugates are on the product side. So when you look at this, we have to be able to learn how to identify what's the conjugate base and what's the conjugate acid. So we always look at the reactant side first. I always say look for the hydrogen, see what's happening with the hydrogen. So you can see over here, we have this funny looking formula over here, and it ends up being this funny looking formula on this side. Well, did that thing give away a hydrogen or did it accept a hydrogen? It gave away a hydrogen, that's why it's an acid listed on this side, all right? If it's an acid listed on this side, the thing it becomes on the product side is the conjugate base, okay? So the thing that the acid becomes is the conjugate base. This here went from OH negative to H2O. So that actually gained a hydrogen, it accepted a hydrogen, that's why this is the base on this side. Whatever the base becomes on the product side is the conjugate acid. So same thing down here on this bottom picture, we have H2O. H2O became OH negative on this side. So since it got rid of a hydrogen, it donated a hydrogen, that makes this the acid. Remember, whatever it becomes over on the product side, that's the conjugate base. Our base is the thing that accepts the hydrogen. This went from NH3 to NH4. It went up a hydrogen. So that's why this is the base on the reactant side. And because it became the conjugate, or became the NH4, that's why that's the conjugate acid. So you always want to follow the hydrogens. The hydrogens tell you what's happening. So we're going to look at our practice questions in the packet. So you always look at the reactant side, you look to see what's happening with the hydrogen, okay? So over here, we can see that this, the NH3 becomes NH4 over here, and the HBr becomes Br negative over here. So which thing on the reactant side, remember, which thing on the reactant side lost the hydrogen? The thing that lost the hydrogen is the acid. The thing that gained the hydrogen is the base. How do I know that the HBr lost a hydrogen? Because it went from HBr to Br negative. How do I know the base accepted a hydrogen? Because it went from NH3 to NH4 plus 1, okay? Now remember, the acid, whatever goes with it, that becomes the conjugate base. The thing that goes with the base is the conjugate acid, all right? So we'll look at the next example. So we're looking to identify all 4 of those things again. We want to see what happens with the hydrogen. So HSO4 negative 1 becomes SO4 negative 2 on this side. H2O becomes H3O plus on this side. So which thing lost the hydrogen? The thing that lost the hydrogen is the acid. So the HSO4 negative lost the hydrogen because it was HSO4 negative, and it became SO4 negative 2. So that means this is the base because it went from H2O to H3O plus. The thing that goes with the base is the conjugate acid. The thing that goes with the acid is the conjugate base. Next example, again, follow the hydrogen. See which thing lost the hydrogen. So on the reactant side, we have HCl, and that actually ends up making, it's a terrible arrow, Cl negative 1. The H2O ends up becoming H3O plus. Okay, since the HCl went from HCl to just Cl, this lost a hydrogen, which makes this the acid. That means this has to be the base. Acids and bases are always on the reactant side. The conjugates are always on the product side. So the water became H3O plus, so it went up a hydrogen, so the base, the water, accepted the hydrogen. The base goes with the conjugate acid. The acid goes with the conjugate base. Next example. So we're looking at this again. The HBr becomes Br negative. The H2O becomes H3O. So which thing lost the hydrogen? The HBr lost the hydrogen, so that means that's the acid. The H2O gained the hydrogen, so that's the base. What goes with the base? The conjugate acid. What goes with the acid? The conjugate base. All right, next we have H2O and HI making H3O and I. So the H2O goes from H2O to H3O. The HI goes from HI to I negative. So which species lost the hydrogen, which donated the hydrogen? The HI donated the hydrogen because it went from HI to I negative. So that means the HI is the acid. What has to be the base? The H2O has to be the base because it accepted the hydrogen. What goes with the base? The conjugate acid. What goes with the acid? The conjugate base. All right, and so what we want you guys to do now is the practice on page 8 in your packet, identifying acids, bases, conjugate acids, and conjugate bases. So let us know if y'all have any questions.